In this unit, we're going to review some topics from algebra, and then the reason we're doing this is because we're going to be using this in a geometry context soon. So we're going to look at slope of parallel and perpendicular lines in this video. So if you recall, slope is a measure of the steepness of a line. So how steep is the line? And then usually what I like to visualize when I'm talking about the steepness of a line is if you're walking up a hill or a mountain or a ramp, you know, how steep is it? How hard is it to climb? And are you climbing up as you go from left to right, or are you climbing down as you go from left to right? So if you recall our slope formula, slope, usually we use the letter m, is going to be the difference in the y value, so y2 minus y1, over the difference in the x value is x2 minus x1. And sometimes we'll write this with this triangle symbol, which is actually, in addition to being our triangle symbol, is also a Greek letter delta, which stands for change. So delta y over delta x, which again means change in y over change in x. Okay, that's what that delta means, change. Change, and it's the letter delta. All right, so here are our different possibilities for slopes. We have a positive slope. So again, as we go from left to right, what's happening to the graph? Well, a positive slope rises from the left to the right. So a positive slope would look something like this. That would have a positive slope. All right, and then the next picture, as we go from left to right, we're going down. So again, if you can imagine yourself walking from left to right, we would be going down. This is a negative slope, and it falls from left to right. All right, so there's our negative slope. Let's highlight that line. We've got arrows on both ends. And then next we have a zero slope. So a zero slope means we're not climbing or falling. So a zero slope would just be a horizontal line. And again, think about if you were walking along this line, you wouldn't be going up or going down. All right, and then our last one, this is an undefined slope. So here's our line here. Now, the way I remember, because we have horizontal and we have vertical, this is a vertical line, is we really can't walk up a vertical line. There's no way to walk straight up the side of a building, for example, which goes straight up. So it's undefined slope. Over here, I can walk across it, but I'm not going up or down. That's a zero slope. All right. Then we have our parallel slope property. So in a coordinate plane, two distinct lines are parallel if and only if their slopes are equal. So hopefully you remember this from algebra. And then perpendicular slopes. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Okay, so what that means is their slopes are opposite reciprocals. Notice that's two things here. They have to be opposite, so one is positive, one is negative, and they have to be reciprocals. All right, so that's a quick review of slope and parallel and perpendicular, and in the next video we'll look at a few examples. As always, if you have questions, make sure you get those answered, and if you feel like you need to rewatch, that's a great idea too. So we'll see you next time.